Hey guys, so this is going to be solving quadratic equations with complex roots. So we're going to go over a lot of stuff in this video. This assumes though that you've already been able to solve quadratic equations with real roots. It assumes that you know what quadratic formula is. It assumes you know about factoring. It assumes that you understand the relationships between zeros and x-intercepts. And also the relationship between x-intercepts, zeros, and factors. Okay, so we're going to just take it up a notch, and now we're going to do everything that hopefully you already know about quadratics, and we're going to add complex roots to it. So let's think about this. So what types of roots are possible for quadratics? And we'll see a visual representation of it here. Well, in one case here, right, the parabola could hit the x-axis in two spots, in which case we have two real roots. So one situation is we could have two real roots. So I say roots, but roots, zeros, intercepts, right? But these are real numbers. We can see them when we graph the parabola on the real plane. Okay, so that's one situation, right? You got a parabola, you hit it on two intercepts, okay? Or you find two answers when you do quadratic formula. All right, what's another situation? Well, your parabola could hit at exactly one spot on the x-axis, so you have one real root, but it has multiplicity of two. So one real root, but it has a multiplicity of two. For instance, our root for this polynomial, for this quadratic, is going to be 3. But the multiplicity of 3 is going to be 2. So we have one root, but it occurs twice. So it's the same root. It's equal. Okay, so that's another situation. The last situation, and the situation that we're going to focus on primarily in this video, is going to be, okay, well, I have a parabola and it doesn't visibly cross my x-axis at all. So prior to this, what we would say is we would say, oh, well, there's no solution. Or we would say no real roots. Or we would say something like no intercepts, right? There was a whole lot of no here. But what actually we're going to, I don't know why I don't just use my eraser tool. What we're going to say now is no, we don't see any visible real roots, but there is in fact two complex roots. Two complex roots, and that will be our last situation. So complex roots always occur in a complex pair, in complex conjugate pairs. So if we have one complex root for a quadratic, we're actually going to have both roots be complex roots, and they're just going to be complex conjugates. Okay, but this is the third situation that we could be in. So to recap, we could either have two real roots, we could have one real root, but it has a multiplicity of 2, or we could have no real roots because we have two complex roots. Now the reason why the parabola doesn't cross the x-axis is because this graph is on the real plane, not the complex plane. If it was on the complex plane, we would see something a little bit different. So let's trash this. So those are our possibilities for roots. So the next kind of natural question is, well, how do we know what types of roots we have? And suppose we can't look at the graph, right? Because if we back up one, we could see what the graph looked like, right? This graph touched twice, this graph touched once, and this graph didn't touch at all. So that's one way. Okay, graph it, look at the intercepts. So you're going to have two intercepts, one intercepts, or no intercepts, and that'll tell you everything you need to know. But suppose you don't have a graph, what we can also look at that's going to tell us this information without solving it out completely is we can look at the discriminant. So as a review, the discriminant is everything that's under the square root in the quadratic formula. So it's your b squared minus 4ac. So it's that piece. So forget about the square root. We just want to know the b squared minus 4ac. So we already know from the previous slide, this guy had two real roots. This guy had one real root. And this guy here had two complex roots. So let's look at what the discriminant looks like for each of these and see if we can figure out a pattern. So the discriminant for this guy, so b squared, so negative 6 squared minus 4 times 1 times c, which is 5. So let's see, this is 36 minus 20, so 16. Okay, so the discriminant of our first quadratic was 16. And this had two roots, two real roots. So what about our second quadratic? So again, b squared, so negative 6 squared minus 4 times a, which is 1, times c, which is 9. Remember, a coefficient, b coefficient, c coefficient. So this is 36. 4 times 9 is also 36, so 36 minus 36. So our discriminant here is 0. Okay. So one real root, we had discriminant of 0. Two real roots, we had a discriminant of 16. Two complex roots, let's see what our discriminant is. So our b is negative 1 squared minus 4 times a times c. Negative 1 squared is 1 minus 12, so we get a negative 11. All right, notice we have three very different types of numbers here. 16, we have a positive number. 0, we have a 0. Negative 11, we have a negative number. So what's the pattern? Positive discriminant implies two real roots. If you get a discriminant of 0, that implies one root, multiplicity of 2. And if you get a negative discriminant, that implies two complex roots. And that's how you can tell the nature of your roots before you even solve it out. So you kind of know what you're looking for just by looking at the discriminant. So the discriminant will tell you off the bat, hey, this will have two roots, this will have one root, or we're looking at something that's complex. So that's how we know what type of roots we'll have. Now, we can figure out the type, yes, but more specifically now, okay, now I want to know exactly what they are. So how do I figure out exactly what they are? So there's a couple of different strategies we can use, and you can use a combination of these. So your first strategy at your disposal would be factoring, right? If you can factor it from factors, you can find your zeros. Or if you can graph it, right? If you have two real roots, you can graph it, pick out your x-intercepts, and those are your zeros. Or we can also do quadratic formula. I'm going to use quadratic formula because quadratic formula will tell me my roots no matter if I'm real or complex. Okay, so quadratic formula will always work, and I always like just doing the one thing that's always going to work. So for the rest of these examples, I'm going to be using quadratic formula. So, for example, like this. So solve this equation. So to solve quadratics, remember we set it equal to 0, so let's add 5 on both sides. Plus 5 equals 0. Now I'm going to set up quadratic formula. So negative b, so remember here's our a piece, here's our b piece, here's our c piece. So negative b, so b is already negative, so negative negative is positive. Plus or minus the square root of b squared. Negative 4 squared is 16 minus 4 times a times c. All over 2 times a, which is 1. So let's see. Well, if we judge by our discriminant here, what's going to happen? Well, 16 minus 20 is going to be negative. So I can tell right off the bat, because that's negative, I know I'm going to be looking for complex roots. Okay, so I already kind of know what to expect here. So we have 4 plus or minus the square root. 16 minus 20 is going to give me negative 4. All of this over 2. Okay, let me simplify my square root of negative 4 using my complex number knowledge. Square root of negative 4 is 2i, so we have 4 plus or minus 2i over 2. Let's simplify further because everybody can divide by 2. And now what do we get? 2 plus or minus I over 2. So if we really split this up, this would be 2 plus I over 2, and I'll simplify this further. So that's really 1 plus I over 2, or 2 minus I over 2, which again, if we split up, 2 divided by 2 is 1, minus I over 2. So again, notice our complex roots occur in complex conjugate pairs, right? 1 plus I over 2 and 1 minus I over 2. All right, so that's our first example. For our second example, find all the roots of this, okay? Well, that basically just means set it equal to 0 and solve it. So again, I'm going to use quadratic formula. So quadratic formula says negative b. So again, there's my a piece, there's my b piece, there's my c piece. So negative b, so negative 6 plus or minus the square root of b squared. So that would be 36 minus 4 times a, which is 9, times c, which is 5, all over 2 times a, which is 9. All right, let's do some arithmetic. Negative 6 plus or minus the square root of 36 minus 4 times 5 is 20 times 9. That's going to be 180. So 36 minus 180. All of this is going to be over 18. Hey, 36 minus 180, this is going to be negative. So these are going to be complex roots again. All right, so again, I look at my discriminant in here. It's going to be negative. So again, I'm looking for complex roots. So negative, which implies that I'll have complex roots there. So this will be negative 6 plus or minus square root of 36 minus 180. So 180 minus 40 is 140, but add 4, 144, negative. All over 18. Simplify further. Complex knowledge. Square root of regular 144 is 12. So square root of negative 144 is 12i. So negative 6 plus or minus 12, 12i over 18. Do any of these numbers have something in common? Yes, they do. We all divide by 6. That's going to be a negative 1. That'll be a 2. That'll be a 3. So we divided everything out by 6. Which left us with negative 1 plus or minus 2i over 3. So let's split this and write it correctly. So our first answer then, so x equals negative 1 plus 2i over 3, which is equal to negative 1/3. So I take the real part out, plus 2 thirds I, so 2i over 3. So that's one answer. Or x equals negative 1 minus 2i over 3, which split up is negative 1/3 minus 2i over 3. So these guys would be our answer here. So again, another complex solution. Two complex solution. Again, notice the complex solutions happen in a conjugate pair. Okay, super, super important, especially when we go on to do things like fundamental theorem of algebra. Noticing that complex solutions occur in complex conjugate pair, super, super important. So that was everything. I hope you guys enjoyed the video. I hope you guys learned something. And as always, please, if you guys have any further questions, please don't hesitate to ask.